starting with adaptive, adaptive technology or adaptive artificial intelligence was invented or created at Stanford University. And it was the result of the leading learning scientists sitting down and trying to figure out how they can create artificial intelligence and algorithms that would personalize and differentiate instruction for every student. So if any student would get into a software, that software would detect what they need and provide the right instruction at the right time. So that was the whole thesis that started 50 years ago with Dr. Patrick Suppes. That he was here. You see Patrick Suppes. He was teaching his daughter how to do math, and he read his daughter's book. That was in 1960. Hated it, and he wrote a new book for his daughter that became a widely used math book in the 60s. So 30 years after all the research, Patrick Suppes created the first educational technology company in the world and the first math software in the world. So then, in 1990, he put together this group of teachers, of educators at Stanford, and for 25 years, they just did coding. They basically added exercises and started dealing with that coding that would create the algorithm necessary to do what they were dreaming to do. So 20 studies published afterwards, and 1.4 million students that have tried it out. Well, what came from that was an adaptive engine that has 44 billion data points, 15,000 different exercises, and on average, students that have used with rigor the software, they advance from 1.5 to 2 grade levels on average. And students that take the AP tests, they score twice the national average than the students, than the peers, that, you know, that AP tests already are measuring students that are high achieving. So the students that are using this adaptive engine score twice the national average. The way this works, the way the software is designed, is that students first get some lesson of a specific skill, and then they get immediately assessed. And I'm going to show that very soon. Then the software knows where the student is and places him or her. Then after giving that student more instruction, it goes and makes the students apply what the student learned. When we mean apply what the student learned, it's not only doing exercises. It could be games, it could be some sort of simulations, just to make sure that the student not only memorized the concept, but it has deep knowledge or deep understanding of the concept, which is key, very important. So if the student doesn't understand, then I'll show you what it does a little bit later. But it goes back and starts reteaching again. But when the student masters the concept, he or she will go to create. And in create, we have designed a huge amount of digital project-based learning tools, such as design tools, coding tools, and simulations, that students, once they master the skill, they can go and apply them into real-world context. For example, when students finish a mathematical concept, a video of a NASA professional can pop up, and the NASA professional would say, here at NASA, I use what you just learned to design satellites. Let's design a satellite together. And then students are given certain parameters and certain exercises that they have to complete, and then they start in a blueprint designing a satellite that has to actually fly, has to get up, has to lift, and then orbit. And how it lifts and it orbits is based on the calculations that the student made. So then we have coding tools such as coding the computational sequence of a self-driving car. And then students are actually starting to learn the basics coding skills in order to design a safe self-driving car. We also have simulations of evacuations of cities due to oncoming hurricanes, and students kind of like simulate, based on the amount of people and where they are, how is the most efficient way to evacuate the city before the hurricane comes. So it's very exciting, because one of the things as math teachers that for us is very frustrating is that students on and on and on say, why I'm learning this? What am I going to use this for in the future? I don't get it, this is boring. But then you show them how STEM professionals are actually doing this. And we, in every single exercise that they use, or many of them, we plug in videos of very young and cool STEM professionals saying, this is what I do in my line of work. So, let me continue here.